Good afternoon, and thank you for joining this episode of Transwestern Talks. Joining us today are Katie Sakach, Kevin Boltz, and Jake Williams, part of our own Asset Services Dream Team. They will navigate the mechanical, technological, and operational considerations that come into play when taking steps to safeguard indoor air quality from COVID-19. We will take Q&A after the presentation, so be sure to ask your questions in the Q&A section of the chat. Jake?
Thank you, Kim, and good afternoon, everyone. Appreciate you joining us today. I'm Jake Smith, Director of Operations for Asset Services, and with me today is Katie Sakach, Managing Director of Asset Services, Kevin Boltz, our National Director of Engineering for Asset Services. You'll see here in a little bit, Kevin is just a wealth of information with this technology we're going to be speaking of. And one of the other key members who can't be on the call today, but has been very integral in this research is Brett Williams, Managing Director of Asset Services. So, as everyone knows, the world has changed in the last 4 to 5 months with COVID-19 pandemic, and we're all adapting to a new way of life and a new way of operating our buildings. We're also adjusting to all the new information that continually changes. I have no envy for the folks over at the CDC, and we're constantly seeking that balance of speed and accuracy with this information that can help combat the spread of the virus. So what we've learned so far is that the virus is transmitted in 2 primary ways: through the air and through surface contact. So today we're covering part 1 of a 2-part series entitled COVID-19, Technology and Operational Considerations, with a focus on indoor air quality. So we'll be covering part 2 in the near future with a focus on surface contact and healthy building certifications. So as Kim mentioned, if you have any questions, please type them in the chat. We'll answer them at the end. And with that, I'd like to turn it over to Katie and Kevin, who walk us through our discussion today. Katie?
Great. Thank you so much, Jake, and thank you, Kim. And I thought I'd say a few words before we start. As you all know, this pandemic has been and continues to be rapidly evolving. We continue to learn daily, and especially because of how quickly this has evolved. We really are taking our guidance from experts such as the CDC, FDA, ASHRAE, UL, EPA, and BOMA. We encourage you to check out each of these organizations' websites. They're constantly updating their websites, and they've been amazing and great resources for us. Much of the information you're going to hear today really was derived from these organizations. So we do encourage you to check out their websites. So with that, we'd love to get started and dive right in. And so guys, what's out there, right? Well, the answer here is there is a lot. Although there may be many technologies out there, today, Kevin Boltz is going to take you through 4 main technologies in today's webinar. Some of these technologies have been around for years, while others are emerging. So as you can see on the screen here, we're going to be covering today bipolar ionization, needlepoint bipolar ionization, UV lighting, and air filters. Now, what's important before Kevin dives in, it's very important to understand that although these technologies are out there, we do need to be mindful about our buildings and the type of systems that are already installed in our assets. So basically, at the end of the day, one size does not fit all. So for example, a type of air filter in one type of building and with that building's air handling system may not work for a different type of building's air handler system. So Kevin will take you through this, and it's important to realize that and to learn about these different systems and how they can be best applied to what you have within your buildings. So thank you so much. We look forward to sharing this information today. And with that, I'd love to go ahead and hand this over to Kevin.
Hey, thanks, Katie. Appreciate everybody joining the call today. As Katie mentioned, we will go over the 4 major types of indoor air quality devices that we have researched recently. First being bipolar ionization. The big question is, what is it? Bipolar ionization essentially is a device that's placed within your air handlers. It has a set of high voltage electrodes that release a charge of atoms. They inclusively induct themselves and deactivate any harmful airborne contaminants. They're placed typically within HVAC systems, out of the public view, that type of thing. They neutralize and enlarge particles. So in a nutshell, they attach themselves to viruses or particles in the air, which make themselves larger. And being larger, they then get captured within the filter system. A couple of the big pros to bipolar ionization would be that it cleans coils, it combats bacteria, kills off VOCs, which are volatile organic compounds such as odors found within the air, and it does kill off some viruses. Some of the cons to bipolar ionization, however, the high cost of installation and operation once it's installed. The system has been known to emit ozone, and there have been no third-party reviews or studies in existence that we have seen today. So next up, we have needlepoint bipolar ionization. It sounds very similar to bipolar ionization. However, the primary difference is needlepoint uses a set of open air needles to attract these particles, rendering them useless. Some of the pros to needlepoint is that they're self-cleaning. It's got a set of rotating brush heads that clean the needles and keep it efficiently working. Most of them, I should say, are UL listed as a zero ozone emitting device, and they have the capability of monitoring live and real stream within your BAS. The cons to needlepoint bipolar ionization that we have seen is the initial high cost of installation, and then over time, those needles that I mentioned earlier eventually have to be replaced. So those would be a couple of the pros and cons that we have. GPS, as it's stated on our slide here, is Global Plasma Solutions. They are kind of the industry leader when it comes to needlepoint bipolar ionization that we've researched, and have been a good partner of ours when it comes to researching ionization technology.
Excellent, Kevin. And one of the things I know we were talking about earlier this week that really kind of brought it to life for me is just the same type of technology that's used in something that we use a lot of times in our daily life, which is Febreze. So I don't know if you wanted to say a word or two about that. It's kind of the same type of technology here.
Sure, definitely. So typically what happens when the ionization system is emitting ions is it sends out either a positive or a negative ion. Those ions then attach themselves to either a negative or a positive ion, rendering them harmless. So if you have a positive VOC ion, the needlepoint system will send a negative ion that will attach to it, and they'll essentially, become harmless as they cancel each other when we're attracted to one another. So the system is very capable of, producing good ions that will help clean the indoor air quality of your air handler.
Excellent.
Next is ultraviolet disinfection lighting. It goes by many different names: UVC, UVGI. If you see UVGI, it's ultraviolet germicidal irradiation. And what it is, in a layman's terms, would be ultraviolet radiant energy that uses short wavelengths within 200 and 280 nms that act and kill off or inactivate any microorganisms that pass through the spectrum. This comes into play with HVAC systems, escalators, elevators, lobby and common areas. The longer the air can sit, or the device will sit in front of, a bacteria-ridden place, it neutralizes and kills those bacteria, kills off the VOCs better. Some viruses, and has been known to kill off pathogens. The pros too is it's been around for close to 50 years. It cleans coils and air handlers very well. Combats the bacteria and the VOCs and some viruses. The cons that we have with UVC is, annual maintenance. So there's lamp replacement that you need to do annually. The requirement for protecting the inside of your air handler or any device that it's in, being that UV is technically the sun, it deteriorates plastics fast. So anything within your air handler needs to be protected. And then your electrical consumption obviously will go up. So those are just a few of the cons and pros that we have with UV lighting technology.
Right, and Kevin, thank you for that update. Another thing to talk about with UV is there are some safety considerations that we should really pay attention to. So, and again, with the variety of applications that we're seeing with UV lighting, there are some safety warnings that go along with it. So what we do encourage you, if you are looking toward deploying a type of UV type of system for disinfection, please look into the PPE that's required, because there can be some areas and instances where there could be overexposure to skin and eyes, and that's something that's very important to enlist your experts and to really understand the type of UV that you'd like to look for or you'd like to deploy. As Kevin mentioned, there's several different types, and then also the location of where this will be deployed. And then in that location, if there are other special safety considerations that do need to be, implemented into your deployment.
Yeah, great. Thanks, Katie. Lastly, filters have been a huge discussion of ours, as well as Katie mentioned, the CDC, ASHRAE, EPA. ASHRAE's current recommendation is to increase a filter to a MERV 13 or higher. The MERV rating specifically stands for minimum efficiency reporting value. High efficiency particulate filters are what are better known as a HEPA filter. Those are typically what you would see in a hospital setting, surgery room. Due to the high pressure drops with HEPA filters, most office complexes are not able to achieve or retrofit an HVAC system with those type of a filter. If you have a facility currently that has a MERV 8 and the system is only designed for a MERV 8, there are specific, statically charged filters that can be applied to a filter media to bring the MERV rating up. But before any of these changes are made, you need to go back to your manufacturer's spec and ensure that HVAC systems can handle the upgrade without any negative impacts on the equipment or airflow. One of the biggest challenges here is to not interrupt tenant satisfaction with the temperature of air that we're providing. So filters have become a big part of what we do, and even though it's last on our slides here, it's definitely one great consideration that we have.
Excellent. Kevin, I know you've mentioned that there's not one size that fits all, but generally speaking, is there any one of these technologies that works better for a particular type of building? Let's say a downtown high-rise, suburban low-rise, healthcare, industrial?
The answer is hard to come there, Jake. I would say first off say no. Every building system is designed differently. Every building system acts differently. So if your air handler, you can put in a higher rated filter, we suggest that you do that. But I would start with filtration. That would be the first one that's recommended by the CDC and ASHRAE. And then from there, if you would like to add on to, your filtration and increasing your outside air has been a big one from the CDC. I certainly would look into UVGI as well as needlepoint or bipolar ionization as additions to the recommended filter change. So to answer your question, unfortunately, there's not a one size fits all. Every building's built a little bit different, but I would start with filter increases first, and then look into the other three as options to help increase better indoor air quality.
Excellent. Great point. Good point. All right. Katie, well, actually, let's Kevin, Katie, you've given us some great information about these technologies, and clearly there's so much information that's out there, and many that we couldn't even get to today. Kevin, could you highlight a couple of the success stories that we've seen, utilizing these technologies?
Yeah, absolutely. We had a case study where we particularly had a facility that could not go above and beyond a MERV 8 filter. However, the owner still wanted to achieve a better MERV rating within the facility. There's a lot of challenges with that. Could the HVAC system handle it, so on and so forth. But ultimately, our resolution here was to replace a traditional MERV 8 filter with an electrostatically charged MERV 8. And according to ASHRAE, it meets the recommended MERV 13 rating when installed. So ultimately, we took the MERV 8s that were in the system out, replaced them with the electrostatically MERV 8, and that meets the ASHRAE MERV 13 guidelines, and gave our owner the satisfaction that they were increasing their filter.
Gotcha.
We've got one more case study here on needlepoint bipolar ionization. It's a little different than the previous case study. The facility was able to increase their filters to a MERV 13. However, the owner was looking for something more. Just as I was saying, they're looking for something in addition to the ASHRAE recommended MERV 13 upgrade. So the challenge here was, how can we improve our indoor air quality above and beyond a MERV 13? So we looked at a multitude of options. We ultimately came down with Needlepoint bipolar ionization as being the best option for them. So our solution here was, we installed and designed a custom Global Plasma Solutions Needlepoint system for them. They also, with the installation, added the active live monitoring to their BAS system to ensure that not only is the device putting out the proper amount of ions, but downstream are they collectively becoming negative and harmless as they're going down the downstream. So this is just one case study of many that we've worked on where we've been able to utilize technology in increasing our indoor air quality for our owners, our tenants, and everybody entering the building.
Excellent.
Oh, that's wonderful. So Kevin, thank you so much for covering those 4 types of technologies. And I know that what we did today is we really, kind of took this from a high level, but also tried to make it a clear summary of what's out there. So, understanding we covered a lot of information, I'd like to take some time to kind of recap the key points of these topics that we covered today. So overall, we've really learned that if deployed thoughtfully and with the guidance of experts, these technologies really, along with other operational considerations, really could help support a healthy building environment, okay? And so of these 4 technologies, we have the bipolar ionization, Needlepoint bipolar ionization, UV lighting, and how you can utilize air filters correctly in your building. Our key takeaways, of course, are make sure to please do your research into these 4 topics. Kevin covered a lot of really great points, along with pros and cons that help to support, what may or may not work for your specific asset. Also know your asset. Every building is different. Every building has their own type of equipment that operates within that asset. So again, know your building, know what your systems are capable of. We also encourage you to enlist with your experts. So your experts can be MEP engineers, could also be, checking out and doing a lot of research through the CDC and ASHRAE websites. And we're also available to help support any questions you may have when it comes to these types of strategies. And then again, we can't say this enough, and I know Kevin and Jake, always have said this in the beginning too. One size doesn't fit all. So as you had learned today, the air filters in one building in particular, a MERV 13, will not work perhaps in a different building because of the type of system that's installed. And that also goes for UV lighting and also for bipolar and needlepoint bipolar ionization. So overall, there are some really great technologies out there that can really support a healthy building environment. We do know the CDC, the FDA, ASHRAE, they are all looking at these technologies specifically for COVID, and they're currently analyzing and research their, efficacy on COVID-19, but they are proven for some viruses that have been around for a while. But because this is so new, this is still under investigation. But regardless, what we have learned and what we're hearing from our experts are these types of strategies are helpful in supporting a healthy building environment in general.
Excellent. Thank you, Katie. Thank you, Kevin. And with that, we'd like to open it up for some Q&A. Kim, do we have any questions out there?
We do. We have a couple. So the first question is, has anyone looked into hydroxyl or hydrogen peroxide generators? There is a type that can be installed on air handler units and can run continuously while occupants are in the building.
I can answer that one. We have looked into generators such as that. And it goes back to you have to make the path of travel for ductwork, hundreds and hundreds of feet. So I would say on a smaller closed air handler, that could be an option. The downfall with that is the replacement of having to put, peroxide in the unit continuously, day after day, depending on how much you use. as well as it's still not a proven disinfection method by the CDC or ASHRAE or the EPA. But it is something that we have looked into. Wouldn't say that it's off the list as something that we would recommend, but it certainly would take some more research to look into.
All right, next question. You mentioned ionization may release some levels of ozone. What effect does this have on lead?
I haven't looked into lead as of having an effect on that, but I know lead does take ozone into consideration. So they probably would not allow the installation of bipolar ionization system because of lead. So the recommendation there would be to go to a needlepoint system and it's no ozone. Ultimately, we're kind of leaning towards putting devices that have zero ozone emittance in the building anyways. The last thing we want to do is emit decent amounts of ozone through the air. So I will research Katie or Jake, if you guys could give me who that question came to, I'd love to dive further into that one and respond back to that individual.
Okay. All right, next question. Where is the best location to install needlepoint systems? We are looking at installing between filters and coils. Would this be the correct location?
That is correct. So you can, here's the difference. So you can place a needlepoint system really anywhere in the ductwork, but as mentioned, the best place to install a needlepoint system would be between the filter and the coil. It would then clean not only the coil, but the filters as well. And then it also, as mentioned, makes the particles larger so that, they get caught in the filter. So that's the absolute best place to install a needlepoint system.
And then last question, of the 4 systems that you've talked about, which one do you feel the most confident in?
First, I would definitely recommend changing the filters first. Your filter's the best line of defense you have in terms of capturing particles that come through the airstream. So first off would definitely be upgrading the filters to a MERV 13. If you can reach a 15 without harming the quality of air going through the building or cutting down the CFM, I definitely recommend going to a higher MERV rating. The higher MERV rating you go, the more particulates that it catches, the smaller particles that get caught in the filters. From there on, we've really done a ton of research with Needlepoint and feel very confident with having that live active monitoring, measuring that you're actually producing enough ions through the airstream is invaluable to what you're doing. So if I were to rate it, first would be your filter upgrade and then go into a needlepoint system.
That was our last question. Thank you very much. Thanks again, everyone, for joining us for this week's Transwestern's Talks. Watch for an invitation coming soon for our next one. Thank you and have a great rest of your day.